Right. In our last lesson, that is on, I think it was on Friday, we're doing the consolidation exercise, right? On the consolidation exercise, we didn't finish all of it, so I'll finish up that. Then we'll move on to today's lesson, which is precipitation reactions. Right, so let's just quickly go over what is left here. I think I did 4.5, 1000 joules, calculate the V on V2. Without any calculation involving a formula, determine the reading on V1, explain how you arrived at your answer, right? And the V1 is the one that we explained here to say, let me just open this. The question says, without doing a calculation involving a formula, determine the reading on V1, explain how you arrived at your answer. So for V1, we said, since the voltage here, when you add the two resistors in parallel, you get your answer to be 2, all right? And we found that R was also 2. So it means the voltage here plus the voltage that we have here, if we add them, we just double them, then it will give us V1, right? And we found V1, let me just check what was V1 again. We found it to be 6 volts, all right? So therefore, the answer for the other one becomes 12 volts, because it's 6 plus 6 to give you 12. So resistance of R is equal to the resistance of the parallel branch. Therefore, VR, V for the resistors in series, is equal to V parallel. So it's going to be 6. So it makes V series plus V parallel, which is 6 plus 6 to give you 12 volts. So that's how you get your 12 volts. Then we move on to the next one. The next one says switch S2 is now opened. Switch S2 is now opened. All right. How will this affect the reading on V1 and the ammeter? So if you go to switch S2, where is switch S2? There is switch S2. All right. So we are opening switch S2. When we open switch S2, what are we doing? All right. When we open switch S2, what are we doing? It means we now have a 4 ohm and a 6 ohm only. All right. So by opening this switch, we're taking out the 4 ohm out of the equation, or out of the circuit. So it means the total here is not going to be 2. Now the total, there will be only one resistor here, which is 4 ohm, and this 4 ohm is going to be in series with R, and R is 6. So the total resistance here, it's like series now, just 2 resistors that are in series, right? Therefore, your total resistance becomes 6 plus 4, which makes it 10. So your total resistance increases. Let's see, the first one here, it was 2 plus 2, which made it 4. So now your total resistance increases here, right? Was this 6? No, this was 2, sorry. So it's going to be 2 plus 4, which makes it 6. So your total resistance increases. Your total resistance increases. Initially, it was 2 for R, and the sum of the 4 and the 4 in parallel gave us 2. So it was 2 here plus 2, which is 4. By removing this one, by disconnecting the other 4 ohm, what are we doing? We are increasing the resistance, right? So let's look at what the question wants. How will this affect the reading on V1? How will it affect the reading on V1 here? What would be the answer there for V1? Your V1 is still the battery, all right? The amount of voltage that is taken out of the battery is still the same, right? So your reading here stays the same. The answer does not change there, because the source of the battery is still the same, right? So the answer is remain the same. Why? Because our V1 is measuring voltage across the battery. By us removing this, it won't affect the voltage that is going to be produced by the battery. So that one remains the same. So your V1 remains constant, remains the same. Right, we move on to the next one. 4.7.2, ammeter A. Explain without doing a calculation for 3 marks. All right, so let's go to the diagram and check. Where is the ammeter? The ammeter is measuring total total current. All right, so now what is going to happen here? The resistance here was 4 total. Now what is happening to our resistance? Our resistance is increasing. When resistance increases, what will happen to the current? The current decreases, right? So the answer here is decreases. The current here will decrease for 3 marks. So you need to highlight all the points that you have there. So in such a case, you're going to say decreases. Why does it decrease? It's because the resistance of the circuit increases. Remember, it was 4, now it's 6. Where is the 4 coming from? The 4 is coming from the 1/4 plus 1/4, which is 2/4. You flip it, becomes 4/2. 4/2 makes it a 2. And here we found this was 2. So 2 plus 2, the total resistance was 4 initially when the switch was closed. Now we open the switch. It means we're disconnecting this 4 ohms. So it means we have got a 2 and a 4. 2 plus 4 makes it 6. That's where we see that the total resistance increases. So your answer there is going to be total resistance increases. And when resistance increases, what happens to current? Current and resistance, they're inversely proportional. It's coming from this. Let me just show you here. It's coming from your equation. R is equal to V over I. Right, we haven't done Ohm's law, but just for your understanding here, your resistance is directly proportional to voltage. So the bigger the resistance, the bigger the voltage. And your resistance is inversely proportional to current. So the bigger the resistance, the smaller the current, right? So if your resistance increases, then your current decreases. So that's our conclusion there. Okay, right, so that's what we have for that particular question there. I think that will be the last question for the consolidation activity. Right, so the answer here is remain the same, decreases. Why does it decrease? Resistance increases. When the resistance increases, then current decreases because they are inversely proportional. Right. Any questions on this consolidation activity? Yeah. Any questions? Kimberly, Jolisha, Joshua, Tokozo, and Sani. Any questions? Right?
No, sir.
Okay. Yes. No questions. Okay, fine. So it brings us to the end of term 2. This was term 2. Now we move on to term 3. Term 3 we have started already, so I'm continuing with precipitation reactions. Precipitation reactions. Right, so we move on. Last time we spoke about reactions in aqueous solution. Let me just open that particular activity. I think there's something that we did there. Let me just look at that activity there. Okay, this is the activity that we're doing last time. I just want to go over it. Right, so it says exercise 21. For each of the following, say whether the substance is ionic or molecular. How do you know that a substance is ionic or a substance is molecular? All right. You look at the type of bonds that you have. Right. Number 1, ionic substances. How do you know that a substance is ionic? You look at a metal and a non-metal. Ionic bonds are as a result of the donating and receiving of electrons or transfer of electrons. A metal gives electrons to a non-metal. So you're going to have your cation and anion. So you're going to look for a metal and a non-metal. So you look at the substances here. Which one is do the atoms that are involved or elements that are involved in that particular formula that you're given here, does it have a metal and a non-metal? So ionic, there must be a metal and a non-metal. Molecular, there must be only non-metals, right? Metallic, then there must only be metals, right? So let's start. For each of the following, say whether the substance is ionic or molecular. So we start potassium nitrate. What is the formula? KNO3. K is potassium. Potassium is a metal. Nitrogen, non-metal. Oxygen, non-metal. So it's a metal and a non-metal. So this is ionic. So 1A, ionic. You go to B, ethanol. Carbon, non-metal. Hydrogen, non-metal. Oxygen, non-metal. So it's made up of non-metals only. So this is molecular. We go to sucrose, which is a type of sugar. So it's C12H22O11. Carbon, non-metal. Hydrogen, non-metal. Oxygen, non-metal. So it's made up of non-metals only. So that's molecular. It means it was as a result of covalent bonding. So it's molecular. Next one, you've got sodium bromide. Sodium bromide, you've got sodium metal. Bromide or bromine, non-metal. So it's made up of a non-metal and a metal, so therefore it's ionic. So those are the answers for number one. We move on to the next one. Write a balanced equation to show how each of the following ionic compounds dissociate in water. Okay, let me just check here. There's someone who's sending a message here. Okay, is B ionic due to OH being an ion? Isn't B ionic because of the OH minus? Not exactly, Joshua. Here, the OH is not. It's not ionic. That OH is not ionic. It's an alcohol, yes, but it's not. It's not ionic, Joshua. It's molecular. Right, because basically there you have, okay, there's that electronegativity aspect because of the oxygen, so it's gonna create a dipole, but that substance there is molecular because of covalent bonding. Okay, right, we move on to number two. Write a balanced equation to show how each of the following ionic compounds dissociate in water. Right, so this one I need to do a screenshot, then I write it, I write the solutions here. So quickly, let me do a screenshot. All right, send it to Smart Notes. All right, then let me share this. Okay, there we go. Okay, so that's what we have. Right, so we have a balanced equation. I'll start by writing it here. So we have got A, sodium sulfate. So we're gonna have our sodium sulfate, Na2SO4. So you've got your Na2SO4. Right? It's a solid. So you're gonna put solid. When you put it in water, what is gonna happen? The ions are gonna dissociate. How do they dissociate? Sodium is in group 1, so that's a plus. And there are 2 of them, so it means the charge here must be 2 minus for the sulfate. So you're gonna have your Na, sodium, Na plus, plus SO4, plus SO4, 2 minus, 2 minus. All right, then you balance it. Sodium here we've got 2, and this side here I've got 1. All right, so I put a 2 here to balance. Right, SO4 is 1, SO4 here is 1. Then I put the states, and here I'm going to have aqueous because it's surrounded by water. So I put my aqueous, and here I'm also going to put aqueous here. So I'm going to have AQ here. That's what I have for number 1, for A. Then I go to B. All right, for B, I've got potassium bromide. Potassium bromide, KBr. So I'm going to have your KBr. And the ratio is 1:1. So it means the charge is there. I'm going to have a positive here, and I'm going to have a negative. All right. Then you put them in water, dissolve them in water. Then they're going to dissociate. So I'm going to have K plus plus Br minus. Br minus. Then I put my states. This one I started with a solid. I put it in water. Then I'm going to have aqueous surrounded by water. And this one is going to be aqueous. So that's what I have for potassium bromide. Then the next one becomes your potassium permanganate. Potassium permanganate, that's your C. So I'm going to have KMnO4. MnO4. Right. Then I know potassium is in group 1, so that's a plus. MnO4 is a minus. So I'm going to have K plus MnO4. Right, that's a plus. Looks like a 4. Okay, MnO4 minus. Then you put your states. So that was easy. So you've got your solid. Then you've got your aqueous here. Put your aqueous. Get your aqueous. Then the last one, C. Sorry, D. Right. What do you have? You've got sodium phosphate. So you've got your Na3. Phosphate, PO4. Right. You check your charges first. Phosphate, it's 3 minus. So sodium, you know, it's in group 1, so it's a plus. Sodium is a plus. But how many sodium do we have here? Sodium ions, we've got 3. For sodium atoms bonding here, there are 3. So it means the positive here is going to be 3. So to balance the 3 plus, there must be a 3 minus here. So the charge on the phosphate is 3 minus. All right, then you put your ions, so you're going to have Na plus your phosphate, which is your PO4, 3 minus. Then you balance, right? So sodium ions here, we've got 3, so you need to put a 3 here. Right, phosphate is 1, 1, then it's balanced. Then you put your states, solid. You put your aqueous. You put your aqueous here. Right, that's what you have. Then I think it's clear so far. Any questions? Okay, we'll move on to draw a diagram to show how K dissolves in water. For this one here, it's not a big deal here. What you simply do, you just take your KCl plus and your Cl minus. Those are the charges that you have. So in water, what is going to happen? This K is going to be surrounded by water. So you're going to have your K plus, and water is going to approach it. Right? We know water is angular. So you're going to have your water like that. Right? We know oxygen is more electronegative. So we know this part here is partially negative, and the hydrogen is partially positive. So water is going to approach with oxygen in front. So you're going to have your oxygen. All right, that's your oxygen there, and your hydrogen at the back. So water is going to be surrounding this in that fashion. So you're going to have H here, all of them surrounding the K plus ion. So it's going to do that right around. Right, then the Cl minus, for Cl minus, you're going to have your Cl minus. So the opposite is going to happen. So your hydrogen is going to come first. Right, so you're going to have your hydrogen being in front. So you're going to have your hydrogen bonded there. Then your oxygen at the back, because like charges attract. Like charges repel and unlike charges attract. So you're going to be having your hydrogen in front and your oxygen at the back. because oxygen is negative and the chloride ion is also negative. It's going to be coming like that. So you do that right around up until you cover all that space, and you cover that space. Then that's how it dissolves in water. Right, so that was the activity. I think it was exercise 20 or 21. I'm forgetting what the activity was that. So that's how you're supposed to have done it. Any questions? Any questions? Right, if there are no questions, let's move on to precipitation. I don't know how much time we have. I think 15 minutes. Okay, right. So let's have a look at precipitation reactions. Right, we're going to look at what we call ion exchange reactions. So from the name, it implies in a reaction, ions are swapped between substances. So ion exchange, there's an exchange of ions in that particular reaction. And the ion exchange reaction is a broad term, right, which defines different types of reaction. One of them is the precipitation reaction. So we start by defining what is a precipitate. What is a precipitate? A precipitate is a solid that forms in a solution during a chemical reaction. So when you're doing a reaction, you're going to see maybe something like flakes that are going to be developing in a substance. That's what we call a precipitate. I think I've got a picture somewhere here. Let me just open that picture. Where is that picture now? Okay. So you're going to have something like this, right? So let's say you start with something that is clear, right, colorless. Then at the end of the reaction, you're going to have solid forming inside. This is what we call a precipitate. So it's going to be milky or a kind of powder that is suspended in water. So that's what we call a precipitate, right? So the colors of precipitate are going to be different depending on the reaction. Some are yellow, some are brown, some are creamy, some are white, and so on and so on. So that's what we mean by precipitate. All right, so you can see here, it's a bit cloudy, though the picture is not exactly clear. Right, so we're defining a precipitate as a solid that forms in solution during a chemical reaction. And the reaction that is going to produce a precipitate, we call it a precipitation reaction. So a precipitation reaction is a reaction in which ions in solution may react with each other to form a new substance that is insoluble, right? That is insoluble. That is supposed to be two different words here, right? So please don't get confused here. So I was supposed to put space between insoluble and is, right? Then there are general rules that we have for solubility of salt, right? The general rule is some are soluble, some are not. So you need to roughly know which ones are soluble, which ones are not soluble, right? So we start nitrates, they are all soluble. So by nitrate, what do we mean? Nitrate, we mean NO3 minus, that's a nitrate, all right? So in this case, let me just, I think I should be writing it down somewhere here so that people understand what I'm talking about. Okay, so a nitrate, all right, let me see this. Okay, so nitrate, I think you can see this. Nitrate, that's your NO3 minus, that's a nitrate, all right? So anything that contains this, it's a nitrate. So your nitrate can be, it can be bonded, it can be maybe potassium nitrate. That's a nitrate still because it's bonded to that NO3. It can be magnesium nitrate. All right, so your formulas will be changing depending on the ratio of the charges. So your ratios are going to be changing, and you will be having different formulas because of the pluses and the minus. Here it's plus, here it's minus. So the ratio is 1:1. Here is 2 plus, and nitrate is minus. So that's why we have a 2 there to cover that, to balance the charges. So and so on and so on. So that's your nitrate. Next one, we have potassium or sodium or ammonium salt. So by potassium, that's your K, plus your sodium, that's your Na, plus Your ammonium salt, that's your NH4 plus, ammonium salt. So ammonia, please don't confuse ammonia and ammonium ion, right? Ammonia is NH3, that's ammonia. This is ammonia, right? That's ammonia, right? Then ammonium ion, it's NH4 plus, NH4 plus. That's an ammonium ion, right? This is a substance, and this is a cut ion. This one, ammonium ion, right? Move on to the next one. The next one is your chloride. Chloride is from chlorine, Cl minus, bromide, Br, iodide is your I. So all of these are soluble. So whatever is bonded to them, they will be soluble. But now when it comes to chlorides, bromides, and the iodides, there are exceptions. If that chloride ion is bonded to lead or silver, then it becomes insoluble. So these are exceptions here. What do we mean by this? We've got your, let me just open here. We've got lead and silver. So it means, for example, if I've got chloride, silver chloride, if I've got AgCl, and on the other hand, I've got sodium chloride, right? What does that mean? It means the first one here is insoluble. Why is it insoluble? Because it's bonded to silver, Ag+. But this chloride here is going to be soluble. So it means if I put it in water, it will dissolve, all right? Why? Because sodium ions are soluble, right? But silver ions are not. Then you also have lead, Pb2+. Pb2+, it's insoluble. So if I'm going to have PbCl2, that will be insoluble. So it's going to form a precipitate. Why do we need to know this? Because we want to know which one is going to form a precipitate, which one is not. So if I put this, then it won't form a precipitate. This one will form a precipitate, right? So that's why we need to know these precipitation formulas, or we need to know the solubility of those substances, right? So you've got your lead is going to be insoluble. Mercury, Hg2+, is going to be insoluble. So these are exceptions. Then you go to sulfates. Sulfates is your SO4, 2-, right? So all of them are soluble except lead. So lead is a problem here. We have lead here again, barium here, and we've got calcium. Especially those ions that have got a 2+, right? Most of them, if it's a cation, they won't be soluble. As you can see, lead 2+, mercury 2+, and yes, silver it's a plus. So the ones with the 2+, looks like you just need to know that charge 2+, then it won't be soluble. Then we've got carbonates. Sorry. Carbonates is your CO3 2-. All are insoluble except potassium, sodium, and ammonia. So carbonate, it's your CO3 2-. It's a charge again 2, insoluble. So the 2, whether minus or plus, you can see there, insoluble, right? So it's bonded to 1, that is a plus, then it becomes exception because of that 1. Potassium is a plus, sodium is a plus, ammonium is a plus. So plus bonded to a 2, then makes it insoluble. It makes it soluble. So CO2, all of them insoluble except potassium, sodium, and ammonia. Then compounds with fluorine, so it means fluoride, or yeah, almost all are soluble except, with the exception of, again, you've got your calcium. Calcium is also a 2, strontium 2, barium 2, lead 2. So these 2 pluses are making it to become insoluble, right? Then we've got perchlorates and the acetates, right? Perchlorates is your ClO4-, right? Then your acetates is your CH3COO-. I think I'll show you, I think I have it somewhere here, the formulas, there are the formulas, right? Perchlorate, there's your perchlorate, ClO4-. That's the formula for perchlorate. And chlorate That's your ClO3 minus. So perchlorate has got more oxygens, 4. Right, and chlorate is ClO3 minus. I think there are sweets also called chlorate. All right, maybe because they've got a smell or they use that. I'm not sure. Right, but we've got an ion that is chlorate and perchlorate. Then we've got acetate. Right, acetate is your CH3COO minus. This is the base that you find in vinegar, in acetic acid, or in ethanoic acid. It's part of vinegar. So that's the ion CH3COO minus. We call it acetate. Then there's a nitrate there. Okay, right, we move on. We've got 8 minutes left. What do we have here? We have the last one, it's metal hydroxides. So hydroxide is your OH minus. Your OH, let me just show you on the table here. OH, there's this. OH minus, right? That's the OH, metal hydroxide, OH minus. Right, so Joshua is different with that OH that we had in ethanol, in that question that we're doing there. It's different with this one. This one is an OH minus. That one was oxygen bonded to hydrogen in a covalent bond. This one becomes a bit different here. Okay, right, then that's your OH, and the O2 minus, that becomes your oxide. That's your oxide. And these are other salts that you have: phosphate, PO4, oxalate, you've got your chromate. There's chromate and there's dichromate. All right, we don't have dichromate here. Dichromate, and you've got your sulfide, and so on and so on. Those are some of the ions that we're going to be talking about. Okay, so this is just to give you a rough idea. So every time you need to check whether the substance that is formed is soluble or not, you come to this table and double check. Right, we move on. Writing balanced equation. For you to be able to see what is going to form, you need to be able to write balanced equations. So there are numerous ways of writing balanced equations, right? There are numerous types of chemical reactions that occur in solution. Some of them are shown below, right? So we've got ion exchange reaction. So in an ion exchange reaction, ions are exchanged in that particular reaction, and they're split. There are 3 types. We've got precipitation reaction, which is the one that we are talking about. Then after precipitation, we're going to go to gas forming reaction. A gas forming reaction, it's a reaction in which a gas is formed. An acid-base reaction, it's a reaction in which a proton is transferred, or H plus is transferred from an acid to a base. All right, then we call it an acid-base reaction. These 3 that are in maroon here, they fall under ion exchange reaction. So these ions are exchanged between substances. Then you've got a redox reaction in which an electron is transferred. We'll talk about that, just introduction. Then we'll do this in detail in grade 11. We'll do acid-base reactions and redox reactions in detail in grade 11. Right, then we move on. There's more than one way of representing precipitation reactions on paper. Right, reaction equations can be written in the normal way with phase symbols, and the symbol S represents solid, and it's placed next to the substance that formed a precipitate, or the one that precipitated. Example, we have got silver nitrate, right, and we have got barium chloride. So basically what is happening here, let me just take a screen shot so that you understand what I'm talking about. I just take this, put it on the smart note. All right, resume share. Okay, let me share this. Okay. Yes, it is. Okay. All right. So this is what we have here. Basically, what is happening here? You've got your silver nitrate. So what are you going to do? You're going to look at the charges. This is Ag plus. This is too thick here. Let me just reduce my line. Where are those lines again? Okay. Fine. AgNO3 minus. Those are the charges. This is what you need to know from group of cations, anions, which we did in grade, we did in during first term, the crisscross. And barium chloride, how do I know the charge is here? Chlorine, I know it's in group 17, so it's minus, and barium becomes 2 plus, because the ratio there is 2:1. Right, then I come to silver. Silver is Ag plus, and chloride is minus. The ratio is 1:1. Nitrate, I know it's minus, but there are 2. So it means barium is going to be 2 plus to balance the negatives. So basically in this reaction, what is going to happen here? There's an ion exchange that is happening. Ag is bonded to nitrate. So the positive here is going to take the negative here. Right? So there is an ion exchange that is happening. So Ag that is positive leaves this nitrate and goes and take the negative that is here. That's why the answer that we're going to get is silver chloride. So it means there's an ion exchange that is taken place. Then we've got the nitrate here. It's going to bond with the positive here, which is your barium. So there's an ion exchange that is taken place here. So you, in the end, we're going to have barium nitrate. That's why we refer to this as an ion exchange reaction, because the cation takes the anion of the other substance, and the anion of the first substance is going to take gonna bond with the cation of the second substance. All right, then what are you going to do? You're going to check. We are forming silver chloride. We are forming silver chloride. So you're going to go check now. We have got a chloride and a nitrate here. All right. So remember, nitrates, we said all of them are soluble. So here the nitrate is going to be aqueous. It's going to dissolve because all nitrates are soluble. But now when you look at chlorides, we have got silver. If you go back to the table that we looked at initially, all right, the one that I gave you. Let me just open it here. We're looking at chlorides. If you look at chlorides here, all right, chlorides, they are all soluble except silver. And the one that we formed now, it has got silver. So that's why it becomes, we write it with an S, right? S for solid. It means it forms a precipitate because it's an exception here. It's not soluble, it's insoluble. So on that equation there, on that balanced equation, we have got an S attached to it. S, it means it forms a solid. Nitrates, silver nitrate, aqueous, all nitrates are soluble. So here it's aqueous, it means it's soluble. Chlorides, they're all soluble except that, the one for silver. So this one is aqueous. And this one is an exception. It means this one forms a precipitate. So this one becomes a precipitation reaction. Right, so that's what we have on that particular example that I'm showing you here. Right, so that's what we have. Then you look at the second one, silver nitrate, barium chloride. You also, it's still the same one, but we are representing it differently. Instead of writing S, other sources will use an arrow pointing down, meaning a precipitate form. Another way to represent it, what do? You're going to split these ones into ions the way I did, plus, minus, like 1 by 1. So you're going to have Ag plus, NO minus, barium, like 1 by 1, right? Then you only represent the one that is forming a precipitate as that. That's another way of representing it. And another way is to ignore everything and only deal with the ones that forms precipitate, which is Ag plus, Cl minus. Right, I'm going to stop here. I've got maybe 30 seconds. Any questions? I'll post this. Let's meet on Friday at 2. Then we do we continue with this topic here. Clear?
Yes, sir. Yes, sir.
Yeah. Right, I'll post it. I'm not sure if you'll be able to do the activity, but I'll post and see if I can put 1 or 2 activities for you. Otherwise, I'll post everything on Friday. I'll just check if there's a activity that will be easy for you to answer. Okay, see you on Friday at 2. Thank you.